Welcome to lecture number 2 for EE206 Circuits 1. This lecture we talk about Kirchoffs laws and circuit elements. Now for circuit elements, there's voltage sources, current sources, and resistances. A voltage source is like a battery. It forces the voltage between 2 points to be constant. Typically, one side is called ground, and that forces the voltage A to be like 12 volts. It doesn't have to be. You can put a battery anywhere in the circuit, and that just forces the difference between A and B to be some set voltage like 12 volts. The current through a voltage source could be anything. It will supply whatever current it takes to maintain the voltage. A diamond represents a controlled voltage source. For example, an amplifier. If you want to take a small signal from your cell phone, multiply by 100 to drive a speaker, that'd be like an amplifier, where the output voltage, VAB, is something like 100 times some other voltage, V12. And note that the notation we're using, VA is the voltage to A relative to ground, VB is the voltage to B relative to ground, VAB is the voltage between A and B, that's VA minus VB. Current source is like an LED driver. LEDs, the current tells you how bright the LED is. For a current source, that has the symbol of an arrow that forces the current, or defines the current, in this wire. The voltage can be anything. It's whatever it takes to set the current. There are also control current sources. This would be like a transistor, a current controlled current source, something we cover in 320 electronics. For the passive elements, there's resistors, capacitors, inductors. With the passive sign convention, the current always goes on the plus side. If you do that, then the voltage across the resistor is I times R. There are also capacitors and inductors. Capacitors and inductors turn the circuit into a differential equation where the current through a capacitor is C times the derivative of the voltage. The voltage across an inductor is L times the derivative of the current. We'll get to these later in the course. These also are used extensively in 311 circuits too. For independent sources, you have the voltage source, which can either be this symbol denoting a galvanic cell or a circle, current source, like an LED driver, or the dependent sources that are diamonds. Now, Ohm's law is kind of fundamental in this course. Ohm's law says that the voltage is I times R, and you can think of it several different ways. I could say the voltage is current times resistance, or current is voltage over resistance, resistance is voltage over current. Any way you look at it, you got V equals IR. Voltage, current, and resistance are all related. Power is volts times amps, which if you substitute is also V squared over R, or I squared R. Now, Kirchoffs laws. Kirchoffs laws are some ways to analyze the circuit. Essentially what you're saying is that if I take a closed path, if I take a voltmeter and short the leads, I get 0 volts. If I take any closed path going around a circuit and wind up back where I started, the voltages have to add to 0. That's Kirchoffs' voltage law. The current law is current can't be created or destroyed. The total current coming out of any point has to add to 0. Or another way to say it, current in equals current out. With that, we can analyze circuits. For example, if I have this one, if I want to find what are the voltages V1, V2, V3, V4, the trick is to use conservation of voltage. Around any closed path, the voltages have to add to 0. So the trick is to find some path where I have one unknown. In this path right here, I've got 3 unknowns, so let's not use that path. Over here, I've got 1 unknown. So the trick is to find 2 paths, or a path where there's 1 unknown like this one, and then sum the voltages to 0. And to be consistent, I'm going to go around this blue line clockwise. If I hit the minus sign first, I'll subtract. Hit the plus sign first, I'll add. So around the blue path, I get minus 50, plus V3, plus 23, minus 5, and I'm back where I started. That has to be 0. With that, I can solve for V3. That's 22 volts. Around the red path, voltages have to add to 0. So starting here in the corner, I get minus 23 plus V4 plus 7 minus a minus 6, I'm back where I started, equals 0. V4 is 10. Once I know V3 and V4, I can now find V1. Using the pink path, I've got one unknown, so minus 50 plus V1 plus 10 plus 15 plus 2 plus 7 minus minus 6 minus minus 5, and I'm back where I started, equals 0. Let's just solve for V1 and V2. Here's the path where there's only one unknown. So that gives me minus 23 minus V2 plus 15 plus 2 plus 7 minus minus 6 equals 0. That lets you solve for V2, and V2 is 10. And there's other paths. Once you're done, any closed path's got to add a 0. So I could take this path, wind around. Any path, voltages have to add a 0. That's conservation of voltage. Conservation of current says the current in equals current out. The total current from a node has to be 0. So if I take this node right here, I know that the current out will be minus I1 plus I2 plus 5 equals 0. I've got two unknowns. The trick here is to find a node where there's only one unknown, like right here. If I take this node at point A, I have I1 plus 10 minus 30 equals 0. Or if I do current in equals current out, 30 equals I1 plus 10 says that I1 is 20. At node B, current in equals current out, I6 equals 30. At node C, 24 equals I7. Node D, 5 is I3 plus 2, so I3 is 3. And node E, current in equals current out, I4 plus 2 equals 24. I4 is 22. Once I know those, I can now solve for I2 and I5. At node F, current in equals current out, 20 equals I2 plus 5. I2 is 15. And to get I5, 24 plus I5 equals 30. I5 has to be 6. So that's some circuit elements and Kirchoffs laws. Kirchoffs laws basically say the voltages have to add a 0 around any closed path. The mistake that people tend to make is they don't take a closed path. You got to start and end at the same point. For conservation of current, if I take any closed path, like at this node, current in equals current out. If you satisfy those two, you can then solve for the currents. That's Kirchoffs laws and lecture number 2 for EE206, Circuits 1.